In this video, we're going to discuss sketching the graph of the derivative of a function based on the graph of the original function f. So here, we want to sketch the derivative, not the original function. Here we have the original function is given by f, and let's figure out what its derivative looks like. Well, what is its derivative? Its derivative represents the slope of the tangent line to f itself. For example, over here, if I look at the tangent line, it has a positive value, so f prime is positive. It continues being positive, slope of the tangent line is positive, all the way until here when I hit this peak. Then the value of f prime, or the slope, is going to become negative because the slope becomes negative. So what's important at first when trying to figure out what the graph of f prime looks like is to see where it's positive and where it's negative, and we can do that easily by looking at the slopes of f. First, let's look at the places where the slope is 0. So at this particular point, the slope is 0. So here f prime is equal to 0. Is f prime 0 here? No. The slope is negative here. So f prime is not 0 at this particular point. On the other hand, is f prime 0 here? Yes. This is the place where we get a horizontal tangent line, so the slope of that line is 0. So in fact, f prime is 0 here. The next place where f prime is 0 is up here. We have a horizontal tangent line. The derivative is 0. So in this graph, we actually looks like we have just 3 points where the derivative is 0. This point, this point, this point. Now what happens in between those points? Well, to the left of this first point here, f prime is negative. Between f prime equals 0 and this f prime equals 0, between here and here, f prime is negative. Between this 0 and that 0, f prime is positive. We can see this because the function's increasing. We can see the negativity of f prime here because the function's decreasing. After this point, f prime again is positive, so it continues to increase. Okay, so let's review. We have f prime is negative up until this first critical point. Then f prime is negative in the next interval. We're decreasing, the function f is decreasing. Then f prime is positive up until this critical point, and it continues to be positive afterwards. So now, so that's the graph of f and how we've evaluated f prime. Let's now graph f prime itself. So it might be best to just forget about our original graph at this point. So we're going to get rid of the original graph, erase it from our memory, and work with the information that we obtained about f prime. So what do we know? We know that f prime is positive here, so we should draw a positive function. This will be the graph of f prime. We don't know exactly what it looks like, but we know it's positive. Then we know that f prime is 0 here. So we have to connect the dot to 0. Because being 0 means that you hit the x-axis. The function f prime is negative along this green line. So we know that the graph must descend below the x-axis. It's 0 at this point. So we have to connect up with the x-axis here. Notice that every time we have a critical point for f, we have a 0 for f prime. The function is positive along this interval, but then 0 here. So we go up, but then we have to come down to the x-axis, since f prime is 0 at this point. But then f prime continues to be positive after that point. So here's a situation where we decrease to 0, and then we have to continue increasing after we hit 0, because we know that the derivative is positive after this point. So altogether, this is the sketch, a sketch of f prime.